All right, here was an example of a arc length question from AP test. This is from a free response section. So it shows this graph from 0 to 10. They talk a little bit about the area, and then they do talk about arc length in here. So they tell us that the arc length from the portion of the graph between 0 and 5 is 11, and the arc length for the portion of the graph between 5 and 10 is 18. They talk about some critical points, and that some of this other stuff with area and critical points was some of the other parts to this one. I only listed on here the part about arc length. So one of the questions they did ask is they want us to find the arc length of the graph of y equals h of x from 0 to 20. And they also told us that this function h of x, which is different than this graph up here, this is the graph of function f. They told us that the function h is defined by this, where the derivative is equal to that. All right, so let's see. If we were to find this arc length, and they want us to find it for h here, so that would be the integral from 0 to 20 of the square root of 1 plus the derivative of h squared dx. Now the problem is, though, we don't know what derivative of h is. They don't give us a picture of that one. They don't give us a function for that one. But they do tell us this right here, that derivative of h is equal to this. And we do know some stuff about f. So let's substitute that in. So if we substitute in, 1 plus here, 1 plus, this is now the derivative of f at x over 2 squared dx. All right, how do we figure that out? Well, that function, we could find the derivative, find the antiderivative of if we were to have just f of u, or f of x. So what we want to do here, this looks like a substitution problem. Let's substitute in for x over 2. Since we got a function inside another function there, let's make that substitution. That's the same as 1/2 x, and so the derivative of this would be 1/2 dx. Meaning, if we do our substitutions here, when we substitute in for dx, that would be equal to 2 du. So let's make those substitutions now. So if we substitute, we got that constant 2. I'm going to pull that out of our integral, or outside it's constant. This is now square root of 1 plus f prime of u squared. And then this will become du. But also, if we change this to u, we're going to want to change those limits as well. So what would those limits become? Well, using this statement right here, u at 0, looks like that would stay 0. However, u at 20, that's 20 over 2, that's going to become 10. So our other limit here needs to change to 10. Okay, so next now, let's find that out. This right here now, this statement, we know should, because it's just f now, this should find the arc length here from 0 to 10. Now, we don't have a way of actually finding f prime of u, but they told us enough information up here that I think we know what that ends up being. They said on this graph, the arc length from 0 to 5, so right in here, that arc length is 11. And then right here, this statement tells us that between 5 and 10, so that whole arc length there, that length is 18. And so if we add that up, that should be the arc length of what this integral would give us. So they don't actually expect you to solve that, but now that it looks like that integral up there, we know that this should be 11 plus 18, or 29 is the length of that. If we multiply that by 2, we get the answer of 58. So 58 was the answer they were looking. So this arc length, he had to kind of do some substitution, some U substitution type stuff, and then you had to recognize that that integral would give us the arc length, and they don't expect you to solve it out, but if they're giving you how long that is, you know you could substitute that in place of that, because that's what this one should find the arc length of function f.